Example number 3. Suppose that the ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. A. What is the velocity of the ball after 5 seconds? So in part A, they're asking us to find the velocity. We will use the definition above. So in this case, our variable is a t. So v of t is the limit as h approach to 0 of a, which is t, plus h minus f of t divided by h. We will use the equation of the ball when it gets dropped from above the ground. Okay, now let's go ahead and plug in. So we have limit as h approach to 0 of 4.9 t plus h squared minus 4.9 t squared divided by h. So you notice that this is mean t squared plus 2th plus h squared. And then we will distribute 4.9. Then we have 4.9 t squared plus 9.8 th plus 4.9 h squared minus 4.9 t squared divided by h. We can cancel the 4.9 and minus 4.9 t squared, and also we can pull out the h on the top. So we will get 9.8 t plus 4.9 h. We cancel out the h. Then we will plug in the t equal to 0. The h equal to 0. Then we will get the answer is 9.8 t. And now in part A, they said that what if the time is after 5 seconds? So after 5 seconds, the velocity will be 9.8 times 5 and is equal to 49 meters per second. Now in part B, they said how fast is the ball traveling when it hits the ground. So when it hits the ground, the distance will be 0, right? So s will be 0. That means 4.9 t squared is, it's not 0, but you imagine like this. The ball is from here, from the CN Tower, and it is 450 meters above the ground. So when the ball hit the ground, it will travel for 50 meters. The distance it will travel is 450 meters. So we want to know the time after 450 meters is 450 divided by 4.9, and the t is the square root of 450 divided by 4.9. It's approximately is about 9.6 seconds. The question asks us how fast. How fast means they ask us for the velocity. So the velocity that we did in part A is v of t equal to 9.8 t. And at the route, the time will be 9.6 seconds. So we will just go ahead and plug in 9.6. Then we get the answer is approximately 94 meters per second.